Okay. Good morning, children. Or depending on what time of the day you're watching this, it might just be afternoon if you happen to be my fourth block. Today we're going to finish up lesson 11. I am not at school today because I am sick. I'm going to do my best to not cough, sneeze, sniffle, or snort during this video. And hopefully we can just get through it. We are going to finish up lesson 11. We should have finished lesson 11 on Friday. But because I was absent, we're going to knock out lesson 11 today and lesson 12. So before you leave today, turn in your lesson 11 exit ticket and your lesson 12 exit ticket. Your lesson 12 lesson I'm going to do in a separate video. Okay? This is just for lesson 11. I should be able to knock this out fairly quickly because we already started on this. I'm going to just run through the few things that we started and then knock out that last ordering from least to greatest problem. And then I'm going to leave you to your exit ticket. Do your exit ticket first for lesson 11 and then watch lesson 12 video. Okay? Just to recap right quick for lesson 11, our objective is to write small positive numbers in scientific notation, which we already went over a little bit, but I'll do a small recap. And then we're going to order it from least to greatest written in scientific notation. And I actually have a couple of tricks for that. I did give you the formula for scientific notation again. The formula for scientific notation is A in absolute value times 10 to the power of n. But when we're working with small numbers and numbers that are very small decimal numbers, your formula is A times 10 to the negative n. Okay, so keep in mind that that n for small decimals will be negative every single time. For the warm-up, I'm going to just do a mini recap because we already did this. And really, we only did number 1 because I was pretty sure that number 2 and 3 would take a little bit of extra time. Too much time, really. And I broke these up for you. The other 2 we didn't do because that would have ate up too much time. For number 1, we have 4.5, 45, and then 0.45. We have 54, 0.54, and 5.4. And this is kind of structured as a trick question because naturally you would assume that anything with 45 in it will be less than 54. But we reordered it on the board to show that the smaller decimal numbers at 0.45 and that 0.54 would be the first 2 numbers in order. That is right here. Make sure that you stack those numbers when you're ordering them from least to greatest or even greatest to least. Stack them on top of each other vertically. That means from top to bottom so that you can see clearly and line up the decimal places. That is going to tell you whether something is less than or greater than. Make sure you line up your decimal places. Do not confuse yourself. Next, after 0.45 and 0.54, I moved on and I put that 4.5 next and then 5.4. Last, we had 45 and 54. I asked you to order those. I'm sorry, not order those. I asked you to rank those and determine which one was least and or greater than. I structured it like this. And at the end, y'all determined that 54 was more than 45. If you don't have that in your notebook, take about 5 seconds to write that down because I'm about to move on. You should have it, but in case you don't, you got a couple of seconds. All right, moving along. Moving right on along. In this table, I'm going to read it off right quick. Complete the table as directed during the lesson. The table shows an approximate measurement of various objects, blah, 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 blah. The first thing we did, we crossed out a few of these columns. We crossed out fraction. We crossed out number times a unit in expanded form and exponential form. We are not going to do those. That was aggravating the first time. It was a bit much. And really, we kind of didn't really need it. So we're going to ignore those. Here in this last box, we labeled this scientific notation. And I'm just going to abbreviate, side note. We actually did the first two together. I'm going to give you about a minute to do that third one. I'm just going to review the first two first. We had grain of rice measured in 0.006. We determined that the 6 was in the thousandths place. So in unit form, this is 6 thousandths. I'm going to try my best to write this. And I'm just abbreviating thou with THS on the end. And in scientific notation, I'm going to do my best to do that here. Let me see if I can zoom in. Yes, I can. In scientific notation, bringing a small decimal over to the right will make your exponent in scientific notation negative pretty much every single time, unless there was a whole number in front of this decimal, but of course that's not the case, so we don't have to worry about it. So carrying over, drag your decimal to the right. 1, 2, 3. That's it. We did 3 jumps over. 3 is our exponent. 6 is our A value. But because we hop to the right for a small decimal, your exponent is negative. So that gives us 6 times 10 to the power of -3 for this small decimal number. I'm going to do spider silk with you. Zooming in again. Once again, we're going to count how many jumps we take over to that 4 because our A value cannot be less than 1. But it also cannot be higher than 9.99. The book is going to say 10, but really that's not correct because 10 is a double digit and your A value can never be a double digit. So here we go, we're jumping. Make sure you are writing this in your book. You're writing what I'm writing. Do not forget. Here we go, from the decimal. 1, 2, 3, 4, 5, 6. Jumps to the right. If it helps you, you can label your jumps to make sure you're not miscounting, especially if you have a lot of jumps. Like if you have more than 6, 7, I would label these just in case. Now we carried our decimal all the way over to the end of that 4. 4 is our A value times 10. We made 6 jumps, so that's our exponent, but we made 6 jumps to the right for a small decimal number. So our 6 is negative. Okay? I'm going to show you how to do white blood cell first. I'm going to give you time to do water molecule on your own, but we're going to go backwards for this 2 times 10 to the -6. I'm going to show you how to go backwards for that. Matter of fact, put a star by this. Going from scientific notation to standard form. Okay? We had 2 times 10 to the -6. Because that 6 is negative, I already know I'm going to make a bunch of jumps to the left, because we went to the right when we were taking it out of standard form, putting it into scientific notation. So when we're working backwards, we need to do things in reverse. So we're going to move to the left, coming out of scientific notation back into standard form. We got 2. In scientific notation, our decimal is there. We're going to jump to the left 6 times to put it back into standard form. Here we go. 1, 2, 3, 4, 5, 6. That's our decimal. Filling your empty spaces with zeros. Okay. Just to determine the place value right quick, here's tenths, hundreds, thousands, 10,000s, 100,000s, millions. So this place value for this 2 here will be 2 millionths. Millions. Okay. Also for this 4, we determined the same thing. I'm assuming that you have this already, but just in case you don't, this was 4 millionths as well. You can write a small abbreviation, just as long as I know what you're talking about. I'm going to give you about 60 seconds to convert this 0.000000003 measurement for water molecule into scientific notation. Feel free to go ahead and put it in unit form. If you're unsure, it's okay. I'll do it for you after the fact. But take 60 seconds to knock that out. Starting now. About 30 more seconds if you're not complete. Make sure you are making jumps on your paper. Do not just count the zeros. That is the wrong answer. Drag your decimal place over to the end of the 3. Ten. 5. 1. For water molecule, I'll knock out the unit form first. From this second 0, that's our tenths place, hundreds, thousands, 10,000s, 100,000s, millions, 10 millions, 100 millionths, billions, 10 billions place. So that 3 sits at the 10 billionths place. Now really you can note that as 30 billionths, but just for the sake of practicality, 3 10 billionths. Put that THS on the end. Don't forget that. All right. Going from decimal, aka standard form, into scientific notation. We're going to drag this decimal place here all the way to the right. We're going to count as we go. 1, 2, 3. You finish counting. You should have counted 10 jumps. Make sure you annotate that underneath, okay? And I'll just put a couple numbers underneath there. So we made 10 jumps, aka we moved 10 decimal places to the right. So we're going to write that in scientific notation. 3 is our A value. Times 10, that part never changes. We made 10 jumps, but we went from a small decimal into scientific notation to make it large enough for that. So we're going to make it negative. They give you 3 times 10 to the negative power of 10. Okay? Moving on. We started this a little bit, but we didn't really finish. I'm going to give you some of this for you to use and practice with on your own. I'm just going to do a couple with you if I didn't already. If I did do a couple with you already, then this is just a quick recap. So just make sure you're double checking and that you understand. Here, we're going to take a couple decimal numbers for number 2 and number 6 and put it into scientific notation. Then for 3, 4, 5, and 7, we're going to take a few of these numbers out of scientific notation, kind of like how we just did for this white blood cell here, and put it back into standard form. I'm only going to do a couple of those for you. The other 2, you got it on your own. Matter of fact, draw a line between number 4 and number 5. Okay? I'll do 2, 3, 4. You do 5, 6, 7 on your own in your lesson. That's a little bit of practice. For number 7, I do believe, I'm sorry, not number 7, number 2. With 0.0007. I do believe I did this already, but just in case, I'm going to do it again. Much like how we were already doing in the table, we're going to move this decimal place so we can put it into proper scientific notation. Technically, the n value, or your exponent, or your order of magnitude is negative because we have to move to the right in order to make this number large enough for scientific notation. Do not forget that. So if I ever ask you, or if you ever need to explain that, make sure that you take note that we have to move to the right to make this number large enough to be in proper scientific notation form, okay? Making our jumps. Here we go. Drag your decimal place to the right. 1, 2, 3, 4. I'm just going to annotate 4. That's our 4th jump there. That gives us 7. That's the only other number besides 0. We don't need all them zeros, so we can ignore it. That gives us 7 times 10. We made 4 jumps. But we made 4 jumps to the right, so it would be 10 to the negative 4. Just like that. For number 3, we're going out of scientific notation back into standard form. Anytime it gives you a number, just rewrite the number. And when I say the number, what I mean is the A value. Just rewrite the A value. And then we'll drag backwards. We have 2 times 10 to the negative 4. We need to make 4 jumps, but because this is negative 4, that means we need to go to the left. If it was positive 4, we're going to make jumps to the right and make the number larger. But because it's negative 4, we're making it smaller. We're going to the left. Here we go. Invisible decimal place there. 1, 2, 3, 4. There's your decimal place. 4 jumps to the left. Fill in the gaps with zeros. That gives you 0.0002, or if you need the place value, tenths, hundreds, thousands, 2 in the 10,000ths place. For number 4, once again, just rewrite the value that it gives you for your A. We have 2.3. Just write 2 and a 3. Don't worry about that decimal right now. Excuse me, sorry. Our exponent is negative 4. So that means we're going to go to the left 4 times with our decimal place. Our decimal happens to be in between 2 and 3. So from there, in between, we're going to the left 4 times. Here we go. 1, 2, 3, 4. There it is. Done. Fill in those spaces with zeros. So that gives you 0.00023. All right. In your own time, knock out number 5, 6, and 7. I would say if you have questions, feel free to ask, but obviously I'm not there. Skipping past a little bit. Okay, for number 8. For number 8, it wants us to order a bunch of numbers that are written in scientific notation from least to greatest. Now, normally, I would tell you to convert all of these numbers into standard form, meaning take them out of scientific notation so you can see clearly what the actual number is. Okay, and if that's easier for you to do, just to keep from making mistakes on accident, I highly encourage it. But if you don't feel like doing all that wrist work, I'm going to show you another way to do it. First of all, before we do anything, we're going to take this 3.6 and put it in scientific notation. Now you might think, well, Miss Davis, technically, we can't move the decimal place nowhere because our A value is already in between 1 and 9.999. That's fine. If you can remember when we had our formula, x to the power of 0 equals 1. Remember that? And 1 times anything is always that number. We're just going to rewrite this 3.6 as 3.6 times 10 to the power of 0. That's it in scientific notation. Because it's 10 to the 0 will be 1. 1 times 3.6 is still 3.6. Okay? So if you ever need to convert a small decimal number into scientific notation like that, that's how you do it, to the power of 0. Now, just reading off, we got 3.6 times 10 to the power of 0. We have 7 times 10 to the negative 2. 3.2 times 10 to a positive 2. 7.02 times 10 to a positive 4. 6 times 10 to a positive 4, and then 3 times 10 to a positive 2, and 4.6 times 10 to a negative 2. First things first, take all of your negatives, all of your negative exponent values, and highlight those in whatever way you choose. I'm just going to put a little tick mark by it, just so I can know that's what I'm working with first. Because in this case, you don't really need to worry about the numbers at the front off the bat. Your A values, you don't have to worry about those yet. Focus on your exponents. All of your negative exponents will go first when you're ordering from least to greatest. And then we'll worry about our positive exponents. All right? We have 7 times 10 to a negative 2, and we have 4.6 times 10 to a negative 2. Okay? Those are our smallest numbers because our exponents are negative, but they are negative to the same value, being negative 2. Now we focus on our A values at the front, which are 7 and 4.6. All you need to do now is determine which one is larger than the other one. So if I was to rank and rewrite it as 4.6, is it less than or greater than 7? I would hope you would know that 4.6 is less than 7, and we are ordering from least to greatest. So this 4.6 times 10 to the negative 2 will go first, and then this 7 times 10 to the negative 2 would be second. Okay? So we're just going to write that in. 4.6 times 10 to the negative 2. 7 times 10 to the negative 2. For your explanation portion, for your explanation, you would say that 4.6 is less than 7 for that first one. That's why it's in that position, because 4.6 is less than 7. For the 7 times 10 to the negative 2, your explanation would be that though the exponent are both the same, because they're negative 2, 7 is greater than 4.6. That is your explanation for number 2 right here. That though the exponents are both negative 2, 7 is greater than 4.6. I would type all that out for you, but I'll be the next 10 minutes, so I'm not doing that. Moving along. Next, I'm just going to count up from negative 2 going on up in a positive direction. We don't have any numbers that have an exponent of negative 1, so we don't have to worry about it, but we do have one with an exponent of 0. That's at 3.6 at the top. So that'll be next. And I'm just going to label that 3. And here you can put it in scientific notation, but you kind of don't have to. You just put 3.6. And your explanation would be that this number in scientific notation will carry an exponent of 0, which is technically more than that exponent of negative 2. Okay? Moving along, because we got 4 more. Next, we already did the exponent of negative 2. We did the exponent of negative 1, and we didn't have any. We've done the exponent of 0, that's at 3.6. Next, you want to look for numbers with an exponent of 1, but we don't have any. So you want to handle all the ones with an exponent of 2. That gives you that 3.2 times 10 squared, and it's 3 times 10 squared. Now, once again, these have the same exponential value, or the same order of magnitude. So now we focus on the A value, that's the number at the front, the 3 and the 3.2. Once again, you're just going to determine which one is greater than or less than the other one. 3 is less than 3.2, so that would go next. That would be our 4th value in the chart. And then 3.2 times 10 squared will be our 5th value in the chart. Keep it in scientific notation. 3 times 10 squared, 3.2 times 10 squared. And it'll kind of have the same explanation as what we had for the first 2. But if you just want to switch your explanations up a little bit, you can say that 3 times 10 squared is greater than the scientific notation version of the 3.6. If you just want to keep from writing the same thing over and over and over again. And the same thing for the explanation with 3.2 times 10 squared. 3.2 is greater than 3. And it has the same exponential value. Last 2. We don't have any powers of 10 cubed, meaning we don't have any numbers times 10 raised to the power of 3, so we're going to skip over it. But we do have a few numbers with the power of 4 raised over that 10. We have 7.02 times 10 to the power of 4, and we have 6 times 10 to the power of 4. Once again, it has the same exponential value here, which is greater than all the other exponential values. So that's why it's going to go last. Pay attention to that. 4 as an exponent is greater than 2 and negative 2 and 0. So those are going to go last. Those are your heavier numbers. Here though, since they have the same order of magnitude or the same end value, we're just going to rank and determine whether if 7.02 is greater than or less than 6. For those of you who might be a little and trying to figure it out, if it helps, just Add a decimal and a couple of zeros on that 6. And then determine is it less than or greater than. I would hope, excuse me, I would hope that you would know that 6 is less than 7 point anything, because 6 comes before 7 regardless. It gives you 6 is less than 7.02, so that 6 times 10 to the 4 will go next. That would be our 6th value by chance. And then 7.02 will be our 7th value. So I'm going to just write it in the chart here. 6 times 10 to the 4. We got 7.02 times 10 to the 4. And then fill in your explanations. For the explanation with the 7.02, you can say that it has the greatest order of magnitude, or the greatest n value, and the greatest a value of the whole list. And for 6 times 10 to the 4, you can say that though the order of magnitude, or the exponent, is just as hefty, or you can say it's just as equivalent to the n value of 7.02, 6 is less than 7.02. Done. All that means is that even though it has the same exponent, your a value as a front is less than 7.02. That's all. Move it along, move it along. Skipping around. Here we go. This is your exit ticket. Your exit ticket is only 3 questions. Do pay special attention, please, to number 3. It's not as difficult as it looks. If it helps, once again, if it helps to break these numbers up and make it easier for you to see, just make little slashes in between each number where those commas are. Make slashes so you can make it more apparent for yourself how many numbers you have to work with. Okay? Also, your criteria for success, meaning if you just want to get an A on this, all you need to know how to do is take a decimal number, a small decimal number, that's what this is, and put it in scientific notation. But you also need to know how to take it out of scientific notation, put it back in standard form. All that means is it's still a decimal number. So you're just taking it out of scientific notation, back into a decimal number. And then you need to know how to order these from least to greatest. Yet again, pay attention to your exponents, pay attention to your a values. Anytime you're given something or presented with some numbers or a problem where you've been given a formula, rewrite the formula every single time, just so you can have as a reminder. Okay? Rewrite it somewhere at the top of your page. Do not forget to write your name. Do not forget to write the date. Also, write the block. Okay? This should take you about 5-ish minutes, give or take. Hop to it after you watch lesson 12. This is lesson 11. Do not forget to turn this exit ticket in before you leave my class.